Thank you all for coming for today's session. It's great to be here at droidcon London. We'll look at maximizing CI/CD efficiency using AI and a vertically integrated stack. I'm Naveen. I'm a solutions architect with Bitrise. What I do mainly is optimize CI/CD workflows for my customers and make it run faster. I quite enjoy it, actually. So we're looking at efficiency in CI/CD. So in my experience, that boils down to two things: speed and developer experience. And today, we're going to see how AI and a vertically integrated stack can make these better. They're actually interdependent. They're not independent. We'll see that too. So if you look at a CI/CD workflow, broadly, we can say that we have three stages to it. There's a build phase, there's a test phase, and there's a release phase. And across all this, you have the setup and optimization that runs all through. So first, let's take a look at how AI impacts setup and optimization, the changes that it is bringing to setup and optimization, to testing and building. We are seeing an emergence of a new AI paradigm. Currently, what we are using and what we are familiar with is what I call the Web 2.0 paradigm, which is what I call it, which has got the project creation wizards, drag and drop editor, reports, and dashboards. Let's take a quick look at what these look like currently in Bitrise, which I'm familiar with, and other CI/CD platforms, you would also see something similar like that. So let's take a look at this. This is a Bitrise dashboard. Let me go back again. Hang on. All right. And this is me starting a new project. And when you create a new project, it is a wizard. You go step by step. You select your repository, link it to Bitrise, and then authorize and go through a sequence of steps, and that creates the project on Bitrise, right? So that is just a wizard example. And then you're familiar with the drag and drop editor, which is easy set of steps, open source. You can drag and drop, create it. Here you are seeing a graphical relationship being built, dependency being built for among the workflows. And then you would see them run, and you can see how each of those workflows ran. And then finally, you have reports and dashboards that, in this case, VM monitoring first, which you can see how your machines performed. And you also have what we call insights, reports that show you how the builds performed over time. So this is the current paradigm we are in right now, which I call the Web 2.0 paradigm. Let's look at how the AI paradigm is shaping up. This is fast evolving. So first, we're all familiar with the LLM agents and chats that we use. And then what we're seeing is AI agent systems integrated in the product, which I call AI in CI. And the third piece of it is developer environments with LLM and MCP. So let's quickly take a look at each one of them. Right? LLM agents, we are familiar, started with chats, then agentic agents, which had tools and which could do more complex tasks. And the stage we are in right now, we have agentic AI, which can do planning and have great amount of autonomy. And it's still evolving. We are now seeing UI components come into chats as well. So let's look at what I talk about AI agent systems as we are seeing in Bitrise right now, how we're adopting it. So I've, again, recorded a demo to showcase that to you. So this is Bitrise, and these are the list of builds. And what you can see on top here is a failed build. And so I click into it. Then Bitrise AI will analyze that failed build and identify the reason. So here, it is identifying that build logs can be long. So here it is pointing out what the issue was with the build. It says 6 tests completed, 1 failed. Build failed with an exception and identifies what went wrong. And then it suggests a solution below over here. It says we used the wrong ID generation approach. And it says use a different approach. So that's the first part. That's the issue analyzer. Then below, you can see fix with AI. So we have agentic systems which can help you then fix it within Bitrise itself. So this is the AI issue fixer. You start it, and you would see that something is happening. So what it does is it actually starts another build to fix this issue. So let's go ahead and see that build. You can see it's a build fixer that's running. And when you click into it, you can see what it is trying to do. You can see the steps here. It is trying to understand the root cause. Then it is trying to reproduce the test failure, fix the ID generation, and then once it verifies the fix by running tests, it commits the change to the repository. So here, it's successfully, in this case, pushed to the repository, and the PR is active. And this is that pull request. And there are a few things happening here, so I just want to pause and explain that. Here, this part, what you see here is what we call a PR commons feature, which brings the information from the build within the PR itself. And this is what happened before the issue fixer ran. It said test failure. And then you can see here a commit which fixed the ID generation. And let's go and take a look into that commit. And then you can see that this commit was made by the AI within Bitrise. And then there's a third feature, which is the PR reviewer. That kicks in for any commit into a PR, and that's what you see below here, the summary. It creates a summary. It walks through what the changes were. And here's what's interesting, though. We also have a code review as part of the PR review. And it reviewed the code that Bitrise AI had pushed and said there is still another bug. But this bug is related to if it runs as it relates to iOS. The fix that was made would not work for iOS, is what this PR reviewer found out. Our build previously running tests was for Android, and this is a Kotlin multi-platform project. So that is 3 things working together. That is the issue analyzer, fixer, and reviewer, all working to add value to Bitrise builds. So this is what I call the agentic system, multiple agents working together to provide value. And even within the AI fixer, it is not one agent that is running. It spawns off multiple agents that works to solve the problem. And finally, what you see here is the summary of it, which shows on the actual build which had failed previously. So that is the current state of AI within Bitrise that I just showed you. And these 3 features are in various stages of beta. But that's not all. We are working towards more features, and we are trying to bring these all together into a chat-like experience. So this is a mock-up of what we are working towards, and this showcases how we are going to create projects within Bitrise which previously you saw was a drag and drop editor, which is cool, which is the Web 2.0 paradigm. In AI paradigm, it's basically going to be a chat interface. Let's take a look at it. So we had a GitHub project repository. We copy the URL of it, and then we just say, create a new project. And it starts creating a new project, and then it'll show you a chat interface where it'll show you the steps that it's going through. So this is how now you didn't have to go through a drag and drop editor. You don't have to look at the steps. Everything is created. Even though this is the AI chat interface, in the back, it is actually creating a YAML file, right? So the Web 2.0 interface is still useful to review the changes and understand it. So this is one. And we saw the AI issue fixer, and I just wanted to show you how we saw how there was a build running, and you could check that. But we're going to abstract that all away into a chat-like interface and show you that information. So let's take a look at that, how that will shape up. You saw the build that was created. Now, when you click into the build, you will be able to see the AI summary. And then, like I showed earlier, you'll be able to see the auto fix. But what will change is that it'll all be abstracted away into the chat interface, so the experience is seamless, and you can have a more interactive experience. So that's what we're working on, and that's what we call the agentic systems in CI. Now, what's the third part of it? Developer environment with LLM and MCP. So I've played around with VS Code and Cursor here. There are more IDEs with the same integration. Bitrise has an MCP server, so does others. What MCP servers allow is to basically makes it easier for LLMs to do remote tool calls, and it helps discover those tools. So setting up that is very simple in VS Code, just a small JSON with the API token. And I want to show you a use case of solving the same issue that you saw on Bitrise, but this time using an IDE and without having to leave IDE at all. Let's take a look. So this is my IDE VS Code with MCP integrated. You can see that on the bottom left here that the MCP server is running. On the right side, we have the Copilot LLM running. And I asked it to get the latest build log of current branch from Bitrise. It's a KMP demo project, the same project. And so it says, OK, I'm going to make a call to Bitrise to get the build log. The first call here is to identify what is the app when I said from Bitrise and what is the latest build, and then it gets the build log. And here, again, build logs are long. Here it identifies the specific issue and brings out that issue. Because if you bring the whole build log to the context, LLMs won't be able to work with that. So we identify the specific error and brings it out. And then now that I have the source code here, I have the error here, I say, hey, please fix the issue. So agents reviews the code, it reads through all the files, and it identifies a solution. It suggested two. I said, OK, go ahead and do both. So it makes the changes to the source code. Now here, previously it was all happening autonomously on Bitrise. Here it's all happening on your machine with the LLM that you're familiar with and your team has approval for and have configured, et cetera. And then I accepted the changes, right? Once it accepted the change, I asked the agent to validate the changes on Bitrise. So I asked it to validate the changes, and then it tries to identify which workflow to run. There are some things that need to be perfected, because here it called the trigger Bitrise build, but I actually wanted to call the validate Bitrise tool call. So I just gave it, I said, don't do that. Please call the validate tool validated fix tool, and it understood that instruction. It ran the validate code changes. So what it does then, you can see on the left here, what it did was it created a temporary branch, pushed the code onto GitHub, and it is starting a new build. And it says, okay, build in progress. In this particular case, you can continue. It's non-blocking, so you can continue doing what you're doing. The build is running on Bitrise. You can see the build is running now. But the developer does not have to go to Bitrise at all. And now the build ran. After 2 minutes, it showed success. So without having to leave IDE, within the comfortable environment, we're able to use Bitrise, MCP server, and the LLMs to solve and fix the issue. There are a couple of things I want to point out. This is evolving. This is fast changing. There are some limitations here. For example, the updates are streamed not to the chat window, but to the output window. So this is an evolution of MCP that's probably in the next 2 to 3 months, the capability to stream back to the chat window would be there. So then the advantage is LLM may be able to automatically trigger a check without you having to prompt for it. The next part of the evolution that I'm watching is UI components within the chat supported by MCP. So it's not a completely text-based interaction. You might have also UI interactions. OpenAI has started that move with apps within their chat, and MCP, the various implementations of MCP are looking at it. These are things to watch out for that's coming. So we looked at a few use cases. There are more other use cases which I've seen customers do. One is optimize workflows using build data. You can get build data and ask the YAML to be optimized based on that. Some have seen used for predicting build times. Some have used for onboarding, because when somebody comes on to understand what the YAML is, etc., is very useful. Within a workflow, you can use it, you can add a step and add the agentic Claude code or codex with the API key, and then use it for selective testing and even for writing tests. For example, we push a PR. Based on the PR comments, it can write tests. These are still in exploration stages. And final use case I've seen that's interesting is CI VMs, because CI VMs are good at executing code. You know that is secure, so you can link it up to other workflows, innate in workflows or OpenAI agent builders using MCP to run code on Bitrise VMs or CI VMs. For example, a Jira ticket is created that can then trigger a workflow, whether innate in, and then part of it could say, okay, now get the code and do some changes, give it a prompt, and run it on Bitrise VMs. So that's an interesting, could be appealing to a different role, not developers, maybe product managers, for example. All right, so I want to quickly switch tracks now. We looked at AI all this while. We're going to look at vertically integrated stack. So Bitrise has data centers. We have 2 in US, and we're rolling out 1 in Amsterdam in 2 weeks. So let's take a look at what is involved in building a fully vertically integrated stack quickly. The foundation is networking. And then observability is very important. We have built redundancy at every point, multiple connections between nodes and switches, multiple pathways between 2 nodes, redundancy in internet connection providers, and automation for change management. On top of the networking are the machines that actually run the build. For Linux, Linux server use case is widely used, so we don't have a problem there. For Mac machines, we had to turn consumer-grade hardware, that's Mac minis, into server-grade. And so we had to figure out a lot of things there. For example, with M4 Pros, we had to create our own chassis to hold the Mac minis, and so we call it the Bitrise Mini Orchard, because it's holding Apple minis. And so this is the view of Airflow, how it looks like within the our dual plenum chassis. And here you could see the impact of it. There were we saw some thermal throttling of the frequency of the CPUs without our air cooling mechanism, and we managed to remove that with our Mac Mini Orchard. So now on top of this infra host, we have virtualization. We built our own virtualization because so that we can respond quickly to any problems. Image building, we release an image once a week so that our mobile tooling teams have the latest tools available. And distributing these images are tricky because they're large size and it has to go across hundreds of thousands of nodes without impacting any network activity. So these were challenges we had to overcome. And finally, we have instance management, which is to create instances as required. And observability was critical because we had to know how these machines are performing. So even when there were no builds running, we ran builds which were benchmarked to see if there is any performance change in these machines. And on top of all this, we run our CI. But what is cool, though, is that the same infrastructure allows us to have build cache, remote execution, and CI. And so we are working on AI agents that can run on it, code spaces upcoming. So these are some of the capabilities. And having a fully vertically integrated stack, what it gives is max performance to our customers and a reliable CI system. I wanted to quickly touch on a couple of points. Just a couple minutes here. We can increase build speed. We can use identifying the right machine type helps. For example, for DuckDuckGo project, by using 16 vCPU machines with the parallel flag on, we could reduce from 6 minutes 51 seconds to 3 minutes 49 seconds using the right machine type. Now, if you look at the VM monitoring, look at the load average of those machines. You can see that load average is the number of processes running in a minute. You can see with 16 CPU, the number of processes were always below 16. Over here was above 16. So therefore, using this machine helped. But any larger machine did not help because there was so much capacity to spare. The next one is bitrise cache. Using cache can speed up build times. Adding cache is as simple as just drag and drop those steps into the workflow. With remote build cache for DuckDuckGo Android project, we saw it saved 35% of the time. These are other runs with dependency cache and all the 3 caches here. But with build cache saved 35%. We have build cache analysis tools where you can look at each invocations and then drill down, look at the critical path, and compare 2 invocations. Why did one have 50%? Why was the other 43%? You can compare them and analyze it. And finally, using split/parallel workflows is awesome. With unit tests, couldn't see much improvements, but for UI tests, by splitting into shards, we could save 6 minutes per flavor. And then we have a distributed test execution, which basically distributes your unit tests across multiple workers, and we were able to save a couple of minutes there as well. Running release builds in parallel is another great way to save time. And so if you combine these right strategies, as I did, I was able to save roughly 20 minutes on these workflows, especially the release workflow. And we looked at all build, test, and setup and optimization. I want to quickly touch through one last use case that I'm seeing more customers interested in the release. For example, if you have observability integrated into your mobile app, and we have this use case where you start release on Bitrise release management, and then the observability tool observes a new release, and if it detects a spike, then it can make a call out to Bitrise and trigger a Bitrise workflow that will pause the build. And with AI, we can get the crash logs and evaluate and then see what's the problem and hopefully even use our fixer, but at least inform your teams on what the issue was and pause the build rollout and then auto fix and notify your team. So that's the final use case I want to touch with the release workflow. But thank you all for joining today. And if you want to know more of us, please, we have a booth down here. And please, my colleagues are here as well. If you can scan your badges, we can always reach out back to you if you have any questions. Thank you very much.